A mysterious traveller from another star system, 3I Atlas, has slipped into our cosmic neighbourhood. Some say Nostradamus saw a long-tailed sign centuries ago. Scientists see a rare interstellar comet that could rewrite what we know about other solar systems. Tonight we'll put prophecy and physics side by side and ask, did the old seer really foresee the sky visitor that has NASA on alert? Imagine a dim speck on a Chilean winter night, so faint it hides inside the noise of the camera sensor. A robotic telescope sweeps the sky the way a lighthouse combs a black ocean, taking rapid-fire exposures of fields most of us will never look up to see. In one frame, the speck shifts a hair's breadth, in the next it does it again. Software flags the motion, human eyes double-check it. Coordinates and brightness are logged. Within hours, astronomers realise this isn't just another icy rock from our backyard. It's taking a path no local ever takes. They give it a provisional code, then a name that reads like a riddle. 3I Atlas, third interstellar, found by the Atlas Survey. In plainer words, it's only the third known traveller from another star system to wander through ours after the strange tumbling Oumuamua in 2017 and the ghostly comet Borisov in 2019. That third matters. It means we're not looking at a one-off fluke or a once-per-civilization omen. We're seeing a pattern, and patterns are how science learns to speak the language of the universe. The telescope that caught it is part of ATLAS, the Asteroid Terrestrial Impact Last Alert System, built to warn us about small, sneaky near-Earth objects. Years ago, the network expanded south, planting identical wide-field eyes in Chile and South Africa, so the sky could be watched around the clock. On July 1st, 2025, the Chile site reported the moving point of light that would become 3I Atlas, and the first reports already hinted at something extraordinary. Track the path backward, and it doesn't loop the sun, it sails in on an open hyperbolic track from far beyond the Oort cloud. That's the signature of a true interstellar visitor. Interstellar means alien in origin, but not in the sensational sense, alien, as in forged under a different star, in another nursery of ice and dust and faint gravity. The cosmos is full of star systems that are messy, busy places. When planets grow, a lot of leftovers get flung away. Most disappear into the dark. A fraction become drifters between suns. Every so often one drifter crosses our path, and if our instruments are awake and our luck is good, we catch it. We read its motion. We learn what home looks like somewhere else. 3I Atlas is one of those rare messages written in ice. From the first weeks, observers noticed it behaves more like a classic comet than Oumuamua ever did. A faint fuzzy coma, the hint of a tail, the kind of breathable visuals that make even jaded astronomers feel like kids again. Processed images from major observatories sharpened the blur into structure, jets, gradients, texture, and a psychedelic composite made headlines by turning the coma into a multicoloured rainbow. The colours are filters, not reality, but the point stands. Sunlight is waking ancient ices, and the comet is answering with vapour and dust we can analyse. There's a practical reason everyone cares. Chemistry is destiny for comets. When sunlight loosens their ices, the escaping gases and the dust grains act like a confession. Spectra can reveal water, carbon monoxide, carbon dioxide, organics. The ingredients list of a distant kitchen where rocks and worlds first formed. For 3I Atlas, those fingerprints don't just tell us about a comet. They tell us about a whole planetary system we cannot see, around a star we may never identify. That's why Third Interstellar is such a milestone. With each new visitor, we can compare recipes across the galaxy. It's natural to ask, is it safe? The short answer is yes. 3I Atlas doesn't come anywhere near Earth. It loops inside the inner solar system and then slips back out, staying a comfortable distance away while giving scientists a precious window to watch. Its nearest swing by the Sun, perihelion, arrives in late October 2025, but from our vantage point it's buried in the Sun's glare around that time. Don't expect a naked eye spectacle. Expect careful measurements, steady updates, and the kind of deep dive science that pays off months and years later. Now picture the Discovery night again. The Atlas pipeline compares images, checks catalogues, eliminates known asteroids and comets. The newcomer's motion is off, too fast, too open. Within a day, observatories across the world pivot. Follow-up data flood in, polishing the orbit and confirming what the first hint suggested. Even archival Precovery images, older photographs of the same patch of sky, are pulled and re-examined to show where the object had been hiding before we knew to look. Each extra data point tightens the story, not bound to the sun before, not bound after, just passing through. 3i Atlas carries mystery because it carries history. The ices locked inside it might be older than our own sun, a time capsule from a neighbourhood that's never sent us mail before. If you listen closely to how scientists talk about it, you'll hear wonder under the caution. We don't get many chances like this. We learned humility from Oumuamua's weirdness. We learned technique from Borisov's bright tale. Now we have a visitor with both scientific promise and enough activity to read. That's the heady mix, not doom, not drama, discovery. And somehow, even amid the spreadsheets and spectra, romance sneaks in. A speck from another sun wandered into our sky, and a machine in the desert noticed. People, real, tired, joyful people, looked up from their monitors, pinged colleagues on the other side of the world, and realized that on this ordinary night the universe had cracked its door open again. 3i Atlas is not here to frighten us. It's here to remind us that we share a galaxy with countless other kitchens of creation, and that, with enough patience and enough sky watching, their stories sometimes drift to our doorstep. NASA isn't biting its nails over this visitor. It's clearing calendars, waking instruments, and flooding inboxes. The moment 3i Atlas tripped the automated alerts at the planetary defense desks, the first question was the same as always. Is it coming anywhere near us? That answer arrived fast and firm. No. Its track keeps it well away, closest to Earth by roughly 170 million miles, with a swing by the Sun around late October that's still beyond Mars's orbit. Safe for us, perfect for science. That flips the switch from caution to curiosity. Suddenly, the mood in mission control chat rooms and science Slack channels shifts. Not crisis, opportunity. What does obsessed look like inside NASA? It looks like a dozen teams moving in parallel. Orbit modelers at JPL nail down the hyperbolic path, proof it comes from another star, while the outreach folks prep pages so the public can follow the flyby in real time. Instrument scientists draft observation sequences, program managers reshuffle time on space telescopes, and across the agency, mission leads compare notes. If a camera, spectrograph, dust counter, or plasma monitor can possibly glimpse this thing, it gets a plan. NASA even lists the fleet watching for it. Hubble, Webb, TESS, Swift, the new SPHEREX mission, Mars orbiters and rovers, Europa Clipper on its cruise to Jupiter, Lucy, Psyche, Parker Solar Probe, Punch, and the joint ESA/NASAS OHO and ESA's JUICE. The goal isn't one pretty picture. It's a coordinated multi-wavelength biopsy of a comet forged under another sun. First up, a reality check image. Hubble locked onto 3i Atlas on July 21st and resolved a teardrop cocoon of dust streaming off the nucleus. From that view and follow-ups, the team constrained the size of the solid heart to somewhere between a few hundred meters and a few kilometers across, and confirmed that it's actively venting dust. Classic comet behavior, just not from our neighborhood. Speeds, wild but expected. Well over 100,000 miles per hour as it drops toward perihelion. Another signature of a visitor not bound to our sun. These early snapshots weren't about spectacle. They were about sizing up the quarry so every other instrument could be tuned to the right brightness, timing and wavelength. Then came the chemistry play. On August 6th, Webb's near-infrared spectrograph took a first look, with a research team racing to pass those spectral fingerprints, lines and features that betray what's boiling off as sunlight warms ancient ices. Sphere X followed with a campaign from August 7th to 15th designed to map broad spectral features that can hint at water, carbon dioxide, carbon monoxide, and complex organics, the deep pantry list that tells scientists how and where this comet formed. In plain language, Hubble sketched its outline. Webb and Sphere X started reading its recipe. NASA's not scared stance is built on numbers, but the agency's obsessed mode is built on coverage. You don't just watch one pass, you watch from everywhere you can. When 3I Atlas brushed past Mars on October 3rd, Europe's orbiters joined in. ESA's ExoMars Trace Gas Orbiter and Mars Express trained their cameras and spectrometers on the faint fuzz, snagging sequences that showed the growing coma and set the stage for more ambitious follow-ups. Even if some instruments pushed their limits, the payoff is perspective. A different vantage point, a different line of sight through the comet's cloud. That's gold when you're trying to separate what the comet is doing from what Earth's atmosphere or geometry makes it look like it's doing. The obsession extends to happy accidents. As 3I Atlas rounds the Sun, the solar wind pulls a long, invisible ion tail straight away from the light. If the alignment is just right, a spacecraft can drift through that tail and taste atoms ripped from the comet. No rendezvous required. That's why mission planners perked up at a forecast that Europa Clipper, currently cruising to Jupiter, might sit in the firing line between about October the 30th and November the 6th. If the team can power up the relevant instruments during that window, they could catch a shower of charged particles from a worldlet born under another star, turning a routine cruise into a once-only sampling run. It's safe for the spacecraft and priceless for the science. Back home, the cadence is relentless. Ground observatories sweep for changes in brightness and structure. Hubble returns for high-resolution snapshots to track jets and dust loss rates. Webb schedules another spectral peak to watch which ices turn on or off as the comet warms and cools. Meanwhile, heliophysics missions like Parker Solar Probe and Punch watch the solar wind that sculpts the ion tail, giving context for any in situ detections by spacecraft farther out. Think of it as a symphony. Dynamics from the Sun, composition from the comet, geometry from the orbits, all layered into one score. NASA's job is to capture every instrument's part cleanly, so the final mix reveals how comets are built in other planetary kitchens. If you're wondering about risk, even a little, the agency keeps repeating the key facts. 3I Atlas stays distant, never a near miss with about Earth. It ducks behind the Sun for a few weeks around perihelion, and then reappears in early December, still faint, never a naked eye show, before fading as it heads back into the deep. For the public, that can feel anticlimactic. For scientists, it's ideal. Bright enough for the best observatories, calm enough to plan, and far enough to keep the panic headlines away. The real drama is in the data. Behind the scenes, the tempo is all logistics and late nights. Proposals for observing time get fast-tracked. Calibration stars are picked. Exposure times are modelled so the comet doesn't saturate detectors or vanish into noise. Archive hunters scour older sky images, recoveries, to stretch the arc of observations back in time, tightening the orbit and sharpening predictions. Outreach leads spin-up explainers and trackers so the public can follow along. There's even an interactive eyes on the solar system view to watch the visitor thread between the planets. None of this is panic, it's craft. The learned muscle memory of an agency that spent decades turning rare cosmic moments into permanent knowledge. And because 3I Atlas is the third of its kind, comparison is the quiet obsession. Oumuamua taught humility. Not every interstellar object will behave like a tidy comet. Borisov taught familiarity. Some look and act like our homegrown comets, just older and farther travelled. This one might be the bridge, unmistakably cometary, yet flavoured by a foreign nursery. With each spectrum and image sequence, NASA and its partners build a cross-galaxy tasting menu. Ratios of water to carbon dioxide, traces of organics, the size and makeup of dust grains. Those differences aren't trivia, they are the fingerprints of planet formation under suns we'll never visit. So no, NASA isn't scared. There's nothing to be scared of. What you're seeing, the press releases, the gallery updates, the sudden flurry of acronyms, is the sound of obsession turning a brief encounter into a library of firsts. In a few weeks, 3I Atlas will slide out from the sun's glare, give us another look and keep going. The telescopes will move on, the papers will roll out, and tucked inside those plots and spectra will be something quietly extraordinary. A set of answers about a place we can't see, carried to us by a speck of ice that wandered across the dark and into our field of view. That's why the world's biggest space agency dropped everything to watch. If you've ever opened Nostradamus, you know it doesn't read like a weather report. It's a foggy landscape of images, smoke, iron, twin suns, long-haired lights in the sky, stitched into 4-line poems he called quatrains. He wrote them in 16th century French salted with Latin and regional dialects, shuffled them across 10 centuries, hundreds of quatrains, and left most of them undated on purpose. That vagueness is the point, a symbolic deck of cards shuffled for future readers. So when a true sky stranger like 3I Atlas arrives, people instantly reach for those cards and start laying them out on the table. Comets have always been the showstoppers of prophecy. To ancient eyes, a comet wasn't a harmless dust ball warming by the sun. It was a bearded star, a torch with a tail, the heavens breaking character. In Europe, artists painted them above kings and battlefields. In China, court astronomers logged their shapes and colours as omens. In the Middle East, poets turned them into metaphors of upheaval. Nostradamus lived in that world. He was a physician during plague years and a practiced astrologer, the kind who tracked planetary alignments, read eclipses, and wrote almanacs for the coming year. When he evokes a strange star burning for days or a long-tailed sign, he's drawing from a cultural library where sky events have moral weight. That's why the leap from a modern discovery to a Renaissance text feels so irresistible. The moment 3I Atlas made headlines as an interstellar comet, the third of its kind, commenters started fishing out passages about blazing stars and doubled suns, insisting the puzzle pieces click. It's a pattern our minds love. A rare thing happens. An old book mentions a rare thing, therefore the old book must have meant this rare thing, but step back and you see the trap. Nostradamus rarely names places the way a GPS would. He rarely commits to calendar dates, and he surrounds the striking image with elastic language that can bend toward many outcomes. That's why the prophecies seem to hit so often. They are built to be re-aimed at whatever the moment provides. None of this ruins the fun, it just reframes the rules. There are two games people play with Nostradamus. In the first, they try to predict forward, use astrological configurations and cryptic clues to guess what's next. In the second, they read backward, wait for an event and then comb the book for a stanza that fits, what scholars call post-diction. The 3I Atlas story mostly belongs to the second game. The comet shows up. Enthusiasts flip to quatrains about a great star, a hairy star, or an ominous light near a time of turmoil, then they colour in the gaps. That isn't cheating, it's how symbolic literature works in the wild. But it's also why historians are careful to say there's no scholarly consensus tying any single quatrain to this specific interstellar visitor. It helps to know how Nostradamus wrote. Accounts from his era say he sometimes gazed into a bowl of water or a flame to coax images into the mind's eye. He loved anagrams, puns, and mythic names that could point in several directions at once. He layered astrology over politics, so planetary arrangements became metaphors for human affairs. Translate that across centuries and languages, and you can make the same stanza describe a comet, an eclipse, a war, or a royal scandal, depending on what you emphasize. Add the internet's appetite for certainty, and you've got a recipe where could be quickly becomes must be. But there's a deeper reason the 3I Atlas prophecy talk exploded. Interstellar objects feel different. Ordinary comets are family. They come from our own deep freezer, the Oort cloud, and circle the sun in bound orbits. 3I Atlas is a stranger with its bag still packed. It lit a match under humanity's oldest reflex. When the sky behaves oddly, we give it a story. Prophecy offers a particular kind of story, one where meaning is already woven in, where an unexpected visitor isn't random but part of a pattern that includes us. Science offers a different kind of story, one where meaning emerges as we gather light, measure motion, and compare what we see with what we know. Both stories touch something true about us. One protects our hunger for significance, the other protects our hunger for understanding. If you watch how believers connect Nostradamus to 3I Atlas, you'll notice a few common moves. First, they pick an evocative line, say a star burning for days or a sign in the tail. Second, they anchor it to the calendar year by leaning on current anxieties, technological upheaval, political chaos, strange weather. Third, they stitch in an impressive detail from astronomy, interstellar, third of its kind, the closest approach to make the fit feel snug. The counter-argument is quieter but sturdy. The same lines have been used to predict other comets and crises before, and will be used again. The text didn't change, the world did. You can feel the tension between these approaches in the language people use. Prophecy talk leans into must, destined, foretold. Science talk leans into suggests, indicates, consistent with. The first is a pronouncement, the second is a posture. When astronomers describe 3I Atlas, they're careful with verbs. It appears cometary, it is consistent with a hyperbolic path. Spectra suggest water and carbon-bearing molecules. That caution isn't a lack of imagination, it's a way to keep wonder honest. Nostradamus, by contrast, was never staking his reputation on laboratory-grade precision. He was composing symbolic weather for the human condition, and yet there's an overlap that makes this moment feel enchanted. Both prophecy and physics are, in their own ways, pattern arts. Nostradamus listened for rhymes between the sky and the soul. Astronomers listen for rhymes between photons and models. When a rare object like 3I Atlas arrives, both arts light up. The poet's descendants light candles around an old book. The physicist's descendants flip on space telescopes. Each camp asks the same human questions in a different dialect. What does this mean? Where did it come from? What does it say about our place here? If you crave a middle path, try this. Let the Nostradamus associations be a frame, not a verdict. Use the imagery to heighten the sense of occasion, the bearded star, the 7-day blaze, the omen that sends messengers running, and then pivot to what we can actually learn. The prophecy gives the scene its drumbeat, the data fill in the melody. In that blend, 3I Atlas doesn't need to be the exact fulfillment of a 16th century stanza to matter. It becomes a mirror. It shows us how quickly we reach for destiny when the universe drops a surprise at the edge of our vision. There's one more twist worth holding on to. Nostradamus wrote during plagues and upheavals. His readers wanted to know whether tomorrow would be survivable. Our age isn't so different. When people ask whether he predicted 3I Atlas, some are really asking whether the cosmos is chaotic or choreographed, whether the future is a hazard course or a narrative arc. The honest answer is that it can feel like both. This interstellar comet is physically ordinary. Ice, dust, sunlight, yet emotionally extraordinary because it arrived exactly when we were ready to hear from far away. So did Nostradamus see it. No one can prove that. What we can say is that he left a language for moments like this, a way to talk about the shock of the heavens in a century that didn't have our instruments or our math. Today, with telescopes that can taste the vapour of a worldlet from another sun, we add our own language to his. We measure, we compare, we learn. And in the quiet after the headlines, we keep the older language too because it reminds us that knowledge isn't the only human need. Meaning is too. 3I Atlas gives us a rare chance to practice both. When two rare things line up, a centuries-old riddle about hairy stars and an actual traveller from another sun, it's tempting to call it destiny. The mind loves clean arcs. It wants 3i Atlas to be a message addressed to us, stamped and mailed by time itself. But there are two very different clocks running here. One is the human clock of meaning, where symbols echo across ages. The other is the sky's clock of cause and effect, where rocks and ice follow sunlight and gravity without ever glancing at our books. To start with the meaning clock. People collect hits, the way stargazers collect meteor streaks. You watch long stretches of darkness, and when something bright appears, you can't help but gasp and point. Nostradamus gave the world a toolbox of images: flames, bearded stars, doubled suns, strange lights, elastic enough to stretch over new events as they arrive. When 3i Atlas appears during a turbulent year, the elastic snaps neatly around it. The fit feels fated because it's emotionally true. Comets have always shown up in the theatre of big feelings: war, plague, upheaval. We project our anxieties and our hopes onto a patch of glowing sky and hear the universe answer back in our language. Now switch to the sky's clock. The way astronomers decide what 3i Atlas is and where it came from looks almost unromantic by comparison. First there's the detection, several time-stamped images where a single point moves just enough to prove it isn't a hot pixel or a satellite. Then tracklets get linked across nights. Observatories around the world pile up positions against the background stars. Feed those positions into an orbit solver, and you get a path that is open rather than looping, a trajectory from outside the Sun's family, through the inner system, and back out again. That alone answers one of the grand questions. It's not ours, not a visitor from our deep freeze, a wanderer from elsewhere. Beyond motion there's composition. When sunlight warms the nucleus, ices sublimate and the coma blossoms. Point a spectrograph at that faint fuzz and you can read which gases and dust grains are escaping. Water, carbon, bearing molecules, simple organics. Each leaves a set of telltale features. Compare those with what we know from local comets, and you get a feel for how similar or alien its recipe is to our own. That's how science turns a glow into a story. Not by deciding what it means for humanity, but by asking what it tells us about the kitchen where it was baked. Between those two clocks, a third factor sneaks in. Our brains are pattern engines. Give us enough quatrains and enough headlines and we'll connect them with golden thread. Psychologists have names for this. There's confirmation bias, noticing lines that fit 3i Atlas and forgetting all the lines that don't. There's the Texas sharpshooter trick. Fire the shots first, paint the bullseye after. There's survivorship bias. Out of thousands of vague images, the few that seem to match a current event get shared and remembered. The rest vanish in the noise. None of this makes believers foolish, it makes them human. We all do it, even scientists, which is why the scientific method builds in checks, peer review, independent observations, and predictions that could fail. That last word, predictions, is where the two paths diverge most. In the prophecy game, the test often happens after the fact. An event arrives and we search backward for a stanza that can be made to fit. If the comet had appeared a year earlier or later, most of the same lines could be drafted into service with only minor edits to the narrative. In the astronomy game, the test happens forward. From a handful of early positions, you compute where 3i Atlas will be on specific nights, how bright it might get, which instruments have a shot at catching it, and where its tail should point as the solar wind shoves it around. If those calls land, confidence grows. If they miss, your model changes. Meaning is optional, measurement is not. There's also a quieter selection effect at work that masquerades as mystery. We find more fated alignments not because the universe is winking at us more often, but because our tools have gotten good. Sky surveys now watch most of the heavens most of the time. They catch faint, fast movers our grandparents couldn't have dreamed of. The flood of detections makes rare categories, like interstellar visitors, inevitable to spot if you wait long enough. Put a net in the water and you will eventually catch a strange fish. The arrival of the fish doesn't prove the ocean had an opinion about your destiny. It proves the net was in the water. None of this cancels wonder. In fact, it protects it. When someone says 3-Eye Atlas is no coincidence, they're defending a feeling that the universe is threaded with intention, that startling things don't just happen, they happen for. When a scientist says coincidence is enough, they're defending a method. Don't add causes you don't need. Don't inflate your certainty. Between those stances, there's a bridge worth walking. Jung's old idea of synchronicity as a meaningful coincidence. Not a secret push from the cosmos, not an algorithmic fate, but a personal alignment where an outer event arrives at the exact moment it can serve an inner need. By that light, 3-Eye Atlas can be meaningful without being a coded memo. It can be a mirror, not a command. Pragmatically, here's how you keep both the poetry and the proof in one frame. When a Nostradamus line feels hauntingly close to the news, hold it lightly. Ask what human hunger it speaks to: security, justice, renewal. Then ask what the data actually show. For this comet, the data show a safe distant pass, a true outsider's orbit, a chemistry lesson we've waited years to sample. They do not show a threat trajectory. They do not show a cosmic verdict on our age. Meanwhile, the poetry can still do its job. Awaken attention, widen the lens, remind us that the sky has always been the stage where we rehearse our biggest questions. One practical check you can try at home is to make the prophecy game risky. Before the next big sky event, pick a single stanza and write down exactly what you think it predicts. Place, window of time, type of phenomenon, what would count as a miss. If you get it, celebrate. If you miss, update. That simple exercise turns vibe into hypothesis and keeps your love for symbols honest. It's the same discipline astronomers live by when they publish an ephemeris or forecast what a telescope will see. You're borrowing their backbone without surrendering your imagination. And remember that coincidence is not a slur. Coincidence is how the independent stories cropped. 3-Eye Atlas has its own long biography. Tossed from a foreign nursery, dim for ages, warmed for weeks. And we have ours, reading, fearing, hoping, interpreting. That they met in our sky right now says plenty about our instrumentation, our attention, and our appetite for meaning. Whether you call that accident or appointment depends on which clock you're listening to. The comet doesn't care, it will flare, whisper its chemistry, and go. The question it leaves behind is ours. Will we honour both kinds of truth, the one that measures and the one that matters, without confusing them? If you can do that, the debate between coincidence and calling softens. You don't have to pick a team. You can let 3-Eye Atlas be a clean scientific gift and a personal omen for whoever needs one. You can enjoy the chill of an old quatrain brushing against a new discovery without pretending the poem drove the physics. Most of all, you can keep the best part of the human response to the heavens. Curiosity with a spine and wonder with a soul. The sky doesn't sign letters in ink. It leaves trails. We choose what to read in them and what to learn from them before the light fades. What makes this visitor different isn't just where it came from, it's how it behaves in our sky. 3-Eye Atlas arrives on an open, never-to-return path, which tells astronomers it isn't tied to our sun the way homegrown comets are. When you rewind its motion, the track points in from outside the solar system. When you fast forward, it sails back out, gone for good. That one geometric fact puts it in a club of 3 in all of human history and turns every hour of observing time into gold. Yet the bigger twist is that 3-Eye Atlas acts like a real comet. Some interstellar visitors have been maddeningly ambiguous, but this one woke up under sunlight and grew a proper coma. A soft, hazy envelope of gas and dust, plus the first hints of a tail. In other words, it's not just a rock on a strange path, it's an active ice ball we can read. That single detail unlocks chemistry. By splitting the comet's light into a spectrum, teams can ask which ices are boiling off, how much dust it sheds, and how that recipe compares with comets born around our own sun. It's the difference between glimpsing a sealed time capsule and opening it. Hubble set the tone with the sharpest early portrait, a teardrop-shaped cocoon flowing off the hidden nucleus. Star trails streaked behind because the telescope tracked the moving target. From those data, scientists could bound the size of the solid heart, likely somewhere between a few hundred meters and a few kilometers across, and confirm an honest-to-goodness dust plume driven by sunlight. That gives observing teams the confidence to tune exposures and instruments for a living, breathing comet, not a silent shard. Speed is another signature. Even at discovery, 3I Atlas was tearing along at roughly 137,000 miles per hour, quickening as it fell toward the sun. That's faster than typical long-period comets from our own deep freezer, and squarely in unbound traveller territory. Fast matters because it shortens our window, the comet brightens and evolves on a compressed schedule, and observers have to choreograph measurements before the geometry changes. Fast also helps confirm the story of origin. There's simply too much momentum here for the sun to keep. The path itself is strangely generous to science and merciful to nerves. 3I Atlas swings only about 1.4 astronomical units from the Sun, inside Mars's orbit but not close, and never nearer than about 1.8 AU to Earth, which is roughly 170 million miles. Translation, it's far, safe, and still bright enough for the big guns. That combination is rare. It spares us the panic headlines while handing astronomers a target they can study across months with space telescopes and the largest mirrors on Earth. Because it's active and interstellar, the object becomes a natural laboratory for comparing planetary kitchens. If its spectrum shows familiar water, carbon monoxide, carbon dioxide, and simple organics in familiar ratios, that hints at shared recipes across star systems. If the mix skews odd, say unusually volatile rich or dust poor, that's a clue about how planets form elsewhere. Either outcome is a win. Sameness says our system isn't unique. Difference says the galaxy's menu is broader than we thought. That's exactly why NASA lined up a multi-mission campaign. Hubble for high-resolution structure, Webb and Sphere-X for chemistry, plus a supporting cast of heliophysics and planetary missions for context. Even the visuals are doing science. A widely shared cosmic rainbow shot, really a time sequence through different colour filters, turned the faint coma into a neon halo and helped the public see what the instruments measure. That sunlight is waking ancient ices and dragging dust into space. It's pretty, yes, but it's also proof that the coma is alive enough to map, model, and monitor from night to night. For an interstellar object, that's precious. Beauty is evidence. Timing helps too. Perihelion, closest to the Sun, lands around October 30th, 2025, after which 3I Atlas disappears into the glare and then re-emerges in early December. That gives teams a clean before and after on the same comet. One set of spectra as the ices switch on, another as they ebb, all while geometry and solar wind conditions evolve. In past interstellar encounters we either lacked activity or ran out of time. Here, the calendar itself is a feature. Throw in the compare and contrast scorecard and you see why astronomers are excited. Interstellar visitor number 1 challenged our definitions, number 2 behaved like a classic comet. This third case arrives with activity, speed, and a safe, well-spaced track that lets us extract chemistry without the drama. It's a bridge between mystery and measurement, alien in origin, familiar in behaviour. That duality is exactly what the field has been waiting for, because it lets researchers ask big questions with fine tools. How common are our building blocks out there? How different can comet be and still be a comet? What does normal even mean when your sample comes from another sun? Finally, there's the simple human reason this one feels special. We can watch it change. Night by night the coma breathes, the tail lengthens, jets flicker on and off, and the spectrum shifts as different ices take their turn under the lamp of the sun. 3I Atlas isn't just a data point, it's a little narrative arc. Arrival, awakening, departure written in dust and light from a place we'll never visit. The fact that it tells that story clearly, safely, and in time for us to listen is the rarest gift of all. The night 3I Atlas was confirmed as an interstellar visitor. The observation requests began to stack like planes on a runway. Each telescope brings its own superpower, and the trick is to choreograph them so every photon gets used twice, first for discovery, then for meaning. Hubble set the pace with a tack-sharp look on July 21st, catching a teardrop sheath of dust streaming from an unseen heart and tightening the best early estimate for the nucleus to somewhere between a few hundred meters and a few kilometers across. That single image told everyone what kind of target they were dealing with. Not a silent shard, but a living comet worth pointing the best spectrographs at. From there, the baton passed to the James Webb Space Telescope. On August 6th, Webb opened its near-infrared spectrograph and began reading the comet's breath, the faint chemical fingerprints riding the glow. Those first spectra shared later that month hinted at an unusually CO2-rich coma compared with water, a clue to where and how the object might have formed before it was flung between the stars. With Webb, chemistry becomes a map. Ratios of common ices sketch the climate of a long-gone nursery, and subtle lines point to minor species that tell you about sunlight, radiation, and time. More, Webb looks are queued up after perihelion to watch the recipe change as the comet warms and cools. Running in parallel is SPHEREX, NASA's new all-sky spectrophotometer, whose specialty is breadth. Sweep wide, catalogue the glow, and spot patterns that a single deep stare could miss. In mid-August, SPHEREX joined the campaign explicitly to capture the big strokes of 3I Atlas's spectrum and cross-check what Webb was seeing. Think of it as the panoramic mic to Webb's studio microphone. One makes sure nothing loud is missed, the other pulls whispers out of the noise. Together, they turn a pretty fuzzball into a lab sample. The campaign isn't just Earth-bound. When 3I Atlas slid past Mars in the first week of October, Europe's orbiters swung their gaze. ExoMars Trace Gas Orbiter and Mars Express grabbed sequences from a whole new vantage point, taking advantage of geometry we can't get from home. A second viewpoint matters. What looks like a change in the comet from Earth might actually be a change in the way we're looking through the coma. With Mars watching too, teams can untangle those effects and track how jets, tails, and dust flows really evolve. There's also a chance, small but thrilling, for a taste, not just a look. As the solar wind peels an ion tail straight away from the sun, spacecraft far from Earth can find themselves drifting through the comet's stream. For a few days around October 30th to November 6th, the alignment suggests Europa Clipper could sit downwind of 3I Atlas. If the team powers up the right instruments during the cruise, charged particle detectors might catch a passing drizzle of ions from a worldlet born under another sun, a chemistry experiment delivered by space weather. It's a safe encounter for the craft, but an unforgettable data point for the rest of us. Back on and above Earth, the cadence becomes a drumbeat. Hubble returns for more high-resolution snapshots, watching jets sharpen, broaden, or blink out, and measuring how dust production waxes near the sun. Webb schedules follow-ups to see whether the early carbon dioxide dominance holds or yields to water as different layers of ice wake up. Ground-based heavyweights fill the gaps. Big mirrors catch features in visible and near-infrared light. Radio dishes listen for faint molecules. Polarimeters probe dust grain properties that betray how the cometary crust is built. Each cell in that spreadsheet adds one brushstroke to a portrait we couldn't have painted 5 years ago. Planning all this is part science and part stagecraft. Observation windows are tight, brightness changes nightly, and the geometry keeps shifting. Teams model exposure time so nothing saturates and nothing vanishes, pick calibration stars that match the comet's colour, and coordinate target of opportunity triggers so one telescope hands the ball to the next without fumbling precious minutes. NASA's own overview makes the strategy plain. Throw the fleet at it, different wavelengths, different distances, different instruments, because 3I Atlas is a one-pass visitor, and every missed moment is gone forever. And there's a long tail to the story, literally and figuratively. After the October swing by the sun, the comet dives into the glare, then re-emerges for encore observations. Hubble is slated to do ultraviolet work in November, where certain gases sing most clearly, while Webb is booked for a post-perihelion return to see how the chemistry settles once the surface layers are vented. The before and after will let scientists separate which ingredients were just frosting and which are baked into the comet's core. None of this would matter if the visitor were inert. What makes 3I Atlas special is that it's both alien and legible. Forged under another star, yet generous with clues. The space telescopes read structure and spectra. Mars orbiters add parallax and context. A deep bench of ground observatories fills in the nightly heartbeat. If a cruiser like Europa Clipper sniffs the ion stream, we'll even have an in-situ data point to anchor the models. That's the dream for a flying comet lab. Turn light into chemistry, chemistry into history, and history into a broader story about how many ways the galaxy makes worlds. So when you hear that agencies are obsessed, this is what that means. Not panic, but a full-court press. A camera on the edge of space, a spectrograph a million miles from home, 2 orbiters at Mars, a procession of mirrors on mountaintops, all listening to the same faint hiss of vapour and dust from a traveller we'll never see again. The goal isn't just a pretty picture. It's a cradle-to-grave dossier on a fragment of another solar system captured during the few weeks it chose to speak. If you're picturing a sky show, you can stroll outside and see with the naked eye, dial expectations way down. 3I Atlas stays far, closest to the Sun at roughly 1.4 astronomical units, and never nearer to Earth than about 1.8 Ogu, so it won't blossom into a crowd-pleasing beacon. That's actually great news for safety and for science. But it means your plan to see it needs a telescope, patience, and good timing. First, the clock. Around the end of October, 3I Atlas reaches perihelion, but from Earth it's buried in the Sun's glare, on the far side of the Sun. That stretch is a no-go for backyard observing. It's solar conjunction, and the comet is effectively invisible from our vantage point. The good window opens after it rounds the Sun. It slides back into the pre-dawn sky in November, then carries on into December as it fades. Think before sunrise sessions, not evening showcases. How bright will it be realistically? Not bright. Forecasts put the peak around magnitude 11 to 12 as seen from Earth. Far below what naked eyes or small binoculars can catch. Practically you'll want at least an 8-inch 200mm telescope under dark skies to glimpse a faint cottony glow, and even then good technique matters. Don't expect a dramatic tail in the eyepiece. Expect a soft smudge with a tiny brighter core that yields more to cameras than to retinas. If you're planning a session, build around these 3 steps. Step 1. Timing. Aim for the 2nd and 3rd weeks of November, when elongation from the Sun improves and the comet rises ahead of dawn. By late November, it's a pre-sunrise target low in the east, and in December it climbs earlier and a bit higher as it fades. If you can only pick a handful of mornings, dissect them in mid to late November. Step 2. Where to point. Use a live ephemeris or finder chart the day you go out. Do not rely on a month-old map. The SkyLive maintains up-to-date charts and a running distance/brightness panel, and time and date's night sky map can overlay the comet's track for your city. As a rough guide, late November has it low before dawn, shifting through the morning sky. Through December, it slides across Virgo toward Leo while slowly dimming. But again, pull a fresh chart before you leave. Step 3. How to actually see it. Give your eyes 20 to 30 minutes to adapt to the dark. Use a low-power eyepiece first, wide field, then nudge up the magnification once you've found the haze. Averted vision helps. Look slightly to the side of the suspected spot to engage the more light-sensitive part of your retina. If wind or seeing is rough, keep power modest. Contrast, not magnification, is your friend on a faint comet. And never sweep near the Sun during or around conjunction. Wait for a safe angular separation in the pre-dawn hours. Astrophotography flips the script from hard to very doable. Even small smart scope or DSLR rigs can stack short exposures and reveal the coma with more drama than any eyepiece. The key is accurate pointing and tracking, plus a fresh ephemeris so you're centred on the right starfield. A November plan many imagers use: shoot in the hour or two before astronomical twilight, collect lots of 10 to 60 second subs, and stack on the comet's motion to keep the fuzz sharp while letting the starfield trail slightly. The Skylive's daily page makes plate solving straightforward by labelling the immediate field. Expectations keep morale high. 3i Atlas will never rival the brighter 2025 comets that casual skywatchers chase with binoculars. It's a connoisseur target, subtle, historic, and best appreciated with glass and a plan. If you just want a pretty comet to wow friends, follow the Brighter Lemon or SWAN updates. If you want to bag a once-in-a-lifetime interstellar catch, this is the one. A few practical tips for Europe specifically. From mid-latitudes, think Berlin, Paris, Rome, in mid to late November, set an alarm for the pre-dawn window. You're looking low in the eastern sky, so pick a site with a clean horizon. By around November the 20th, the comet can rise several hours before the sun, giving you generous dark time if clouds cooperate. December brings more altitude but also a slow fade, so front-load your attempts. If you like having a checklist, use this. Fresh charts, same day, scope cooled and aligned, low-power finder eyepiece, averted vision technique, and a safe separation from the sun. Log what you see and snap a few images if you can. The science teams love comparative amateur data during these windows. And remember, the goal here isn't spectacle, it's contact. You're catching the faint breath of an object formed under another star, passing our sky once and never again, even as a small, stubborn fuzz. That's worth losing a little sleep for. When something rare glides into view, two parts of us wake up at once. One part reaches for the oldest language we have, omens, messengers, the bearded star that means a turning of the age. The other part reaches for instruments, exposure times, spectra, dust grain models, shared spreadsheets. 3i Atlas sits exactly where those two parts meet. It invites us to hold a myth in one hand and a measurement in the other, and discover they're not enemies. They're different tools for paying attention. Myths are attention engines. They compress experience into images so sticky they outlive empires. A torch in the sky that crowns and condemns. A wandering sign that appears when the world is already trembling. They don't tell you how many miles away the light is. They tell you how close it feels. Microscience, the gentle tyranny of small, careful numbers, does almost the opposite. It refuses the rush of meaning. It asks, what is the light made of? How does it change hour by hour? What exactly can we rule out? If myth is a drum, microscience is a metronome. The wonder is that both keep time with the same event. Watch how that plays out with 3i Atlas. The mythic mind sees a stranger from another sun and immediately sketches a drama. The visitor, the threshold, the audience looking up in the dark. The scientific mind builds a different stage. On it, photons arrive one by one, each carrying a hint. This one touched water vapour, that one bounced off dust. This other was nudged by charged particles streaming from the sun. The drama there is quieter but no less human. A global relay of people deciding at odd hours to squeeze meaning from noise instead of sleep from night. We sometimes pretend one language must swallow the other. Either the comet means something or it is only ice and dust. That's a false duel. Meaning and mechanism answer different questions. Mechanism asks, what is true about the world regardless of how we feel? Meaning asks, what is true about us when we meet that world? When you let them coexist, the picture gets richer. The comet's tail is not a finger pointing to doom. It is gas and dust pushed by sunlight and the solar wind. And still seeing it can mark you, because you make vows when the universe surprises you, to get up earlier, to learn the sky, to become a person who can tell faint from nothing. There is a ritual on both sides. In the mythic ritual, people gather, speak old lines, light candles, and aim their attention at the same patch of sky. In the scientific ritual, people calibrate, point, expose, reduce, and aim their attention at the same patch of sky. The tools differ, the devotion rhymes. An occultation timer is not so far from a prayer bead. A lab notebook is a modern illuminated manuscript. Margin notes, diagrams, a sacred insistence on what happened and when. We're still trying to trap wonder long enough to hand it on. 3i Atlas rewards that devotion because it is legible. It doesn't hide behind the ambiguity that made earlier visitors so slippery. It grows a coma, hints a tale, answers to sunlight with a visible yes. In the mythic frame, that yes is an omen's voice. In the scientific frame, it's a signal with a signal-to-noise ratio you can beat if you're careful. Both frames sharpen when placed side by side. Myth tells you what to feel, microscience tells you what to do. There is of course danger in each. Myth can harden into certainty too quickly. It can draft the comet into whatever story we already prefer, the one where our age is uniquely cursed or uniquely chosen. Microscience can calcify into a different arrogance, the kind that confuses measurable with meaningful and leaves the public outside cold. The antidotes are humble and paired. On the myth side, hold symbols with open hands, let them breathe and surprise you. On the science side, narrate the process, not just the result. Invite people into the kitchen where the recipe was proved or thrown out. You can watch that invitation happen in small ways. A single raw frame of 3i Atlas looks like static until someone circles the faint smear and explains the trick. Line up the images so the comet stands still and the stars become streaks. Suddenly the smear is a thing with identity. That's microscience teaching the eyes to see. Then the other language adds its layer. This smear is a messenger from another nursery, a time capsule of someone else's once upon a time. Suddenly the smear is a character. That's myth teaching the heart to care. Even the words we use are a bridge. In labs, people talk about signatures and lines and families of molecules, story words smuggled into measurement. In temples and comment sections, people talk about signs and portents and messages, observation words smuggled into myth. We have always cross-pollinated. The point is not to police the border, but to keep both dialects honest. If a claim from the prophecy camp can't, even in principle, be wrong, it belongs to belief, not evidence. If a claim from the physics camp can't, even in principle, be explained to the curious layperson, it belongs to gatekeeping, not public knowledge. There's also the personal experiment. Take one morning in November or December, find a dark place with a clean eastern horizon, and try to find 3i Atlas with whatever optics you have. Maybe you succeed, maybe you don't. Either way, you've stepped into the oldest human classroom, the one with a cold breeze, a stubborn object, and a ticking clock. You will learn something practical, how your optics behave, how your eyes adapt, and something more durable, that the sky resists being consumed. It insists you meet it where it is, on its schedule, with your expectations trimmed and your patience stretched. That lesson is moral as much as technical. When you come back inside and pull up the latest plots or persisted images, notice what changes in you. The numbers are still numbers, the pixels still pixels, but they land in a different climate. You can feel the distance those values stand in for. You can feel the human chain that caught them. Myth has done its job. It has kept awe alive long enough for discipline to do its work, and discipline has done its job. It has turned awe into understanding without evaporating the awe. 3i Atlas offers a preview of how we might meet the next wave of rare things. Interstellar planets found by microlensing, biosignature debates on exoplanet spectra, strange transients in the outer dark. If we meet them only with myth, we will fight over interpretations and miss the mechanism. If we meet them only with microscience, we will publish papers that no one remembers and miss the moment to enlarge the human story. Better to braid the two, teach the public how to read a spectrum the way a monk reads an icon, and teach scientists how to write about data without sanding off the wonder that summoned them to the work. In that braid, the old fear dissolves. The fear that if a comet is just ice and dust, it cannot also be a sign. It can. It can be a sign of what kind of people we are when something unrepeatable wanders through our small lives. Do we argue about a headline, or do we go outside? Do we demand certainty, or do we practice attention? Do we hoard the experience, or do we share the finder charts and the tips that let someone else catch the faint breath too? The best part is that this meeting of myth and microscience is self-healing. If the interpretation gets wild, the measurements tug it back. If the measurements get cold, the story warms them. Some nights you'll need the drum, some nights you'll need the metronome. 3-Eye Atlas keeps both in time. A stranger's whisper made visible, a signal pulled from noise, a reminder that our oldest stories and our newest instruments exist to serve the same hunger. To be present, to understand, and to be changed by what we find. What can we actually read from this traveller, and where do the answers stop? Start with its breath. As sunlight warms the surface, 3-Eye Atlas sheds gas and dust that act like a confession. By splitting that glow into its fingerprints, astronomers can tell which common ices are present: water, carbon monoxide, carbon dioxide, and how their proportions change as the comet approaches and then recedes from the sun. That moving recipe is a map back to the freezer it formed in. If carbon dioxide and carbon monoxide dominate early and water follows later, it hints at layers, fragile, super volatile ices near the surface, sturdier water ice below. If water never quite takes over, that suggests it grew up far from any warm star, in a place where the cold never relented. Beyond the headline ingredients, teams will chase the whispers. Trace organics, simple chains and rings built from carbon, sometimes survive in comets. If 3-Eye Atlas is generous, faint features can reveal whether those building blocks look familiar compared to our local stock or skew in odd directions. Even when individual molecules are too faint to name, the overall colour of the coma across wavelengths says something about the average chemistry and the size of dust grains being lofted. Redder slopes in the visible can mean dust-rich and complex organics. Flatter slopes can imply more mineral grit. Polarization, the way scattered light is oriented, adds another layer, helping infer whether grains are fluffy clumps or compact pebbles. Those tiny clues are how we jump from poetry to process, what kind of solids a distant nursery made, how they were glued together, and how easily sunlight can tear them apart. Activity is its own lesson. Watch 3-Eye Atlas night after night and you can measure how quickly gas and dust production ramps up, plateaus and fades. That tempo compared across interstellar visitors and homegrown comets tells us whether comet is a universal behaviour or a family of related habits. Jets, the narrow fans of material that flick on and off as the nucleus spins, are timing beacons. Catch a jet repeating and you've caught the rotation period. See it drift across the coma and you've watched the spin axis precess, or the jet source evolve as fresh areas wake and old events clog with fallback dust. In the best cases, subtle wiggles in the comet's path betray non-gravitational pushes from outgassing. Fit those gently and you get hints about the nucleus's mass and bulk density, which in turn whisper about how loosely that ancient rubble is packed. Dust is a storyteller of its own. When grains lift off, they sort themselves by size under the double pull of sunlight and gravity. By measuring the tail's shape and brightness profile, you can reconstruct the size distribution. Is this comet flinging out a fog of micron-scale powder, or a mix that includes larger, pebble-like clumps? Spectra in the infrared can even tease out mineral fingerprints, silicates with crystal structures that record their heating history. Compare those to the minerals we see in our comets, and you're suddenly looking at how hot or cold the birthplace of 3-Eye Atlas was, whether it saw shocks, ultraviolet irradiation, or long, quiet winters. There's also the weather report nobody sees but every comet feels, the solar wind. As the stream of charged particles from the sun hits the gas outflow, it carves an invisible ion tail, and sometimes creates a delicate boundary where cometry and solar particles jostle. If ground and space telescopes catch the right emission lines, you can watch that interaction evolve as the sun's mood changes. If any spacecraft happens to drift through the downwind region, pure luck and careful planning. Charged particle instruments could even taste the ions that used to be ice inside 3I Atlas, anchoring remote measurements with a point sample. That would turn a good campaign into a once-only laboratory. On the what we'll learn side, one prize sits a bit higher. Isotopes. Ratios like deuterium to hydrogen in water, or heavier to lighter forms of carbon and oxygen, carry a memory of temperature and chemistry in the comet's birthplace. They are hard to measure at this distance and brightness, but not impossible if the comet cooperates and the instruments get enough clean time. Even upper limits help. If the ratios fall inside the broad range we've seen locally, it suggests that planetary freezers across the galaxy might not be so different. If they land outside, it tells us our recipe is one variation among many. We'll also sharpen the big picture demographics. With Oumuamua, Borisov, and now 3I Atlas, we can start to say something about how often star systems eject material and what kinds of bodies survive the journey. A clearly cometary third caser strengthens the idea that icy leftovers routinely get thrown out during planet building. If future surveys keep finding more like this, we'll be able to estimate how much interstellar dust and ice thread the space between stars and how often such drifters should pass through our skies. 3 was an anecdote, 10 or 20 becomes a population. Now the limits. Distance is the first wall. 3I Atlas stays far. That's wonderful for safety. It's brutal for resolution. No telescope will cleanly resolve the nucleus into a shape. It will remain a bright point wrapped in glow. Everything we infer about size, spin and density will be indirect and model dependent. Jet maps can suggest where active regions sit, but they won't draw us a crisp topographic map. Without a dedicated spacecraft flyby, the heart of this object remains a silhouette. Brightness is the second wall. Even at its best, 3I Atlas is a faint target. That means spectra will be noisy, temporal coverage will be patchy, and faint features, especially the delicate lines that carry isotopic stories, may sit below practical detection. Some nights geometry helps, many nights it doesn't. The comet will slip into the sun's glare near its warmest moment, forcing a break in observations exactly when the chemistry is most lively. We'll knit before and after together, but the crescendo happens behind the curtain. There's also the problem of projection. We never see a three-dimensional coma, we see a two-dimensional smear with all the depth stacked onto a single frame, disentangling where material sits. How fast it moves and what direction jets truly point requires models with assumptions. Change the assumed grain sizes, change the solar wind conditions, change the phase angle, and you tweak the story. Good teams bracket those uncertainties. They still remain. When you read later that dust production was X or water release peaked at Y, understand those numbers stand on scaffolding, not bedrock. Origins are where the limits bite hardest. Will we name the star that threw 3I Atlas out? Almost certainly not. Even with a precise velocity vector, the galaxy is a churning ocean. Stars move, local gas flows. A tiny error today becomes a large positional fog when you rewind a few million years. At best, we can say the comet arrived on a path consistent with the general flow of nearby stars or with a known moving group. At best, we can say its chemistry smells like a cold outer disk rather than a warm inner nursery. That's valuable, but it isn't a return address. We also won't learn anything direct about life. Comets matter in origin of life stories because they move water and organics around, and some lab-friendly molecules can be detected in the gas. But organic here means simple carbon chemistry, not living matter. 3I Atlas can tell us whether the pantry of a foreign kitchen stocks similar basic ingredients. It cannot whisper whether anyone ever cooked with them. If a headline leaps that gap, it's leaping past the data. Nor will 3I Atlas settle debates sparked by earlier visitors. Oumuamua's odd behaviour spawned a zoo of ideas. Borisov looked comfortably cometary. This newcomer's active, more familiar face is a clue about probabilities, not a verdict. One clear case doesn't retroactively explain the weird one, and it doesn't rule out that the next surprise will be weirder still. The real lesson is methodological. Keep your models nimble, your claims proportional, and your appetite ready for outliers. Even the NASA is shocked style narratives will meet their limit in the long arc. Agencies are excited and organised. They are not clairvoyant. Teams will ask for time, get some, lose some to weather or to higher priority targets, and make the best of what they get. Some hoped-for lines will be buried in noise. Some carefully orchestrated sequences will be undercut by the comet's own whims. The final papers will include as many upper limits as detections, and that is not a failure. It's how honest astronomy looks. What we will have when the glow fades is a dossier thick enough to matter. A curve of brightness that records how 3i Atlas woke and dimmed. A set of spectra that sketch its main volatiles and hint at its minor ones. Polarization and colour measurements that peg its dust as fluffier or grittier, redder or neutral. Constraints on spin, on non-gravitational nudges, on how sunlight sculpts its outflow. A dozen cross-checks between space and ground, before and after, blue and infrared, that triangulate a personality for a thing we will never touch. And maybe the most important looks mundane on paper: calibration. Every interstellar visitor we catch calibrates our expectations. It nudges our survey strategies, refines our exposure plans, teaches us where the pitfalls hide and where the payoff sits. 3i Atlas, by being both alien and legible, is a teacher. It will leave behind not just numbers, but playbooks. How to pounce earlier next time, which instruments to wake first, which wavelengths carry the richest clues at which distances. That kind of learning is easy to overlook in the rush for headlines. It's also what turns rare luck into routine science, so the promise and the boundary sit side by side. We will learn how a shard of someone else's dawn behaves under our sun. We will not learn the name of its home. We will learn which ices and dusts it carries. We will not read destiny from its tale. We will learn enough to update our models and sharpen our questions. We will not be done. And that's the right shape for wonder. Answers that open further doors. A visitor that leaves us better at listening when the next faint breath appears at the edge of night. So what's the verdict? Did a 16th century poet truly call a wanderer from another sun? The honest answer is Nostradamus gave us a mirror, not a map. He wrote in images that keep their edges soft on purpose. Long-haired stars, great fires in the sky, lights that linger and unsettle. Those phrases are big enough to hold almost any sky event with a tail, and small enough to feel personal when one drifts into our own century. 3i Atlas fits inside that language the way a hand fits a glove. Not because the glove was stitched for this hand, but because leather stretches. If you came hoping for a quatrain with coordinates and a date, there isn't one. If you came for a feeling, the sense that an unexpected messenger has stepped into the scene at exactly the moment we're watching, well, that feeling is real and it matters. But let's be precise about where meaning lands. Nostradamus did not name 3i Atlas. He did not describe an interstellar origin, a safe, distant path, or the faint chemical breath that our instruments are now teasing apart. Those belong to us. We are the first generation with sky cameras that never blink, with space telescopes that can taste the vapour of a grain of dust from another star. In that sense, the prophecy, if you insist on calling it that, wasn't about the comet at all. It was about the readers, the kind of people we would need to become so that a whisper in the dark could be heard. And here we are, not kings trembling under omens, but insomniac teams trading finder charts before dawn, amateurs aligning mounts in frozen fields, students learning to read spectra the way monks once read icons. The old lines gave us a mood. The new tools give us a measurement. The story requires both. So no, the quatrains didn't predict the details. They did something stranger. They kept our imaginations tuned to the sky across centuries when we could have looked down and never looked up again. They taught generations to expect that the heavens might speak, so that when 3i Atlas finally appeared, the world had a word ready for the shape it made in our minds. And still, the verdict stands. Prophecy without dates and places isn't a forecast, it's a frame. Whether you call that a dodge or a gift depends on what you want from the universe. If you want control, you'll be disappointed. If you want a reason to keep watch, you've just been handed one. There's a deeper generosity in refusing to force a match. When we let 3i Atlas be itself, alien in origin, modest in brightness, lavish in lessons, we learn more than any tidy fulfillment could teach. We learn that other planetary kitchens bake comets that behave like ours. They wake under sunlight, shed dust in jets, answer to the solar wind with ghostly tales. We learn that the galaxy is not empty between stars, but threaded with fragile travellers that sometimes wander within reach of our questions. We learn that wonder grows up well. It doesn't have to be caged by certainty to keep purring in the heart. Still, there's poetry here worth keeping. Think of the chain of attention that brought this speck into focus. Night workers in Chile watching for motion. Pipeline engineers writing code that never sleeps. Coordinators slotting observation windows like beads on a rosary. Backyard observers who will never meet the mission leads, but will share a stack of images anyway because that's what it means to belong to the same sky. A Renaissance astrologer would have called that fate. A modern astronomer calls it logistics. The felt truth is the same. Something larger than one person, larger than one night, is moving through us, and we are moving with it. If you want a line to carry away, take this one. 3i Atlas is not an omen, it is an answer. It answers the question, are we alone in the way our worlds are made? With a gentle probably not. It answers the question, can a small distant thing still change us? With a loud yes if we let it. And it answers the quiet, private question that prophecy has always wrapped in metaphor. Is there meaning out there for me? By reflecting it back. Meaning's what you do next. You can turn off the video and scroll, or you can set an alarm for a cold morning, print a chart and try to find a barely there haze that will never pass this way again. You can argue online about what Nostradamus meant, or you can join the living experiment that tells us what this comet means in the only way that matters, by measuring it together. Here's a simple, honest way to hold it all. Treat Nostradamus like a soundtrack, not a script. Let the old music swell when you see a processed image where the stars streak and the comet stands still. Let the drumbeat of long-haired stars add gravitas to the fact that this is only the third confirmed outsider we've ever caught. Then, when it's time to decide what's true, drop the soundtrack to the background and listen to the metronome. The careful counts, the logged times, the comparison across instruments. That rhythm, repeated across 1,000 small choices, is how scattered wonder becomes shared knowledge. And when the glow fades, and it will, you'll have a better story than predicted ever was. You'll be able to say, in the autumn of that year, a stranger from elsewhere wandered under our sun. It was faint. It was fast. It was safe. It was generous. We didn't panic. We prepared. We read its light, we compared its breath to the breath of our own comets, and we learnt that the recipe for worlds travels well. We didn't crown a king or fear the end, we did something braver. We let the heavens be the heavens, and we changed ourselves instead, a fraction at a time, by the discipline of looking. If you need a verdict stamped in ink, stamp this. Nostradamus did not foresee 3i Atlas in any way that a scientist would recognise as a prediction. He did, however, leave us a language that refuses to let rare sky moments pass without resonance. That's enough. The rest is on us. Keep the old book on the shelf. Keep the new charts by the door. Teach a friend the trick of averted vision. Share a finder map. Give your future self a memory of breath in cold air and a smudge that wasn't there an hour ago. Then, when the next interstellar visitor slips into our field of view, we'll be ready, not to shout fulfillment, but to whisper, welcome, and mean it. And maybe that's the quiet wonder at the centre of all this. For most of human history, the sky was a place that did things to us. Now, bit by bit, it's a place we do things with. 3i Atlas is not a sentence handed down, it's a conversation offered. We answer with attention and craft and care. The poet's language gives the scene its hush. The physicist's method gives it its truth. Between them, a door opens. We step through, The visitor keeps going. We remain, changed, tuned, a little more fluent in the language of light than we were the night before.